Once again, welcome to Mathematics Solutions. And today we would like to look at the Newton-Raphson iterative method. So Newton-Raphson iterative method, it is used to find or to estimate or to approximate the solution of the functions of the form f of x is equals to 0. It states that xn plus 1 is equals to xn minus f at xn over f prime at xn. So that is what it states. Now, in this case, we want to solve an equation using Newton-Raphson method. So you have been given a question. Consider the equation. Consider the equation x cubic minus 3x minus 4 is equal to 0. Find a beta approximation to the root by Newton-Raphson method. By Newton-Raphson method. So let us look at the solution. So under solution, we need first of all to estimate where the root will be. And so we can be able to see our function is of the form f of x is equals to 0. So this implies that our f of x is equals to x cubic minus 3x minus 4, which is equals to 0. Now, so we want to understand now what will be f at 0. F at 0 will be 0 cubic minus 3 times 0 minus 4, which is equals to 0. And this implies that it will not be equal to 0, it will be equal to negative 4. It will be equal to negative 4. And you can see this one, it is less than 0. Also can check f at 1 is equals to 1 cubic minus 3 times 1 minus 4, which is equal to what? This is 1 minus 3, which is negative 2, minus 4, you get negative 6. And this negative 6 also is less than 0. We also have to test now f at 3. If you test f at 3, it will be equal to 3 cubic minus 3 times 3 minus 4. And this will give us 27 minus 9 minus 4. We shall get to 14, which is greater than 4. So this implies that, hence, the root of the function f of x is equals to x cubic minus 3x minus 4 is between 1 and 3. That is, at x is equals to 1, between x is equals to 1 and x is equals to 3. So we need to choose our x naught. From our formula, you know that Newton-Raphson method states that xn plus 1 is equals to xn minus f at xn over f prime at xn. Now, we can choose now our x naught to be equal to 1.5, or maybe we can choose any point in between, or we can just choose maybe our x to be between 1 and 3, which is 2. We can choose our x to be equal to 2. But you can choose any point between 1 and 3. So for me, I've just choose to use 2. So this means that when n is equals to 0, the Newton-Raphson method or formula will turn to be x at 1 is equals to x naught minus f at x naught over f prime at x naught. And so this means we're going to have, we need to evaluate our f at 2. So f at 2 will be equal to 2 cubic minus 3 times 2 minus 4, which is equals to -2. And then our f prime at xn will be equal to, we differentiate the function, we differentiate this function, this one here, we differentiate the function f of x to become, it will become 3x squared minus 3. So it's going to be 3x squared minus 3. So if you evaluate f prime at 2, we're going to have 3 times 2 squared minus 3, of which this is equals to 9. So we substitute to our formula. We substitute to our formula to have x1 is equals to x naught, which is 2, minus our f at x2, it is -2 over 9. If you evaluate this one, you'll get x1 is equals to 2.22. So to go to x2, then you have our n being equal to 1. So our n, when is equals to 1, we're going to have x2 is equals to x1 minus f at x1 over f prime at x1. So I want to transit to this other side here. So let us just draw a straight line like that. So from here, we'll go up like that. So from here, we shall go there. So we're going to have, our x2, our f at x2 will be f at 2.22, which will be equal to 2.22 cubic minus 3 times 2.22 minus 4, which will be equal to, this will be equal to 0.281, 0.281. And then f prime at x2 will be equal to f prime at 2.22, which is equals to 3 times 2.22 squared minus 3. And this will give a value of, it will give a value of 11.785. So when we substitute to the formula, our x2 will be equal to 2.22 minus our f at 2.22 is 0.785. 281 over 11.785. So when you evaluate this, you get your x2 as 2.196. So we need to continue with the same iteration until when the next value or the last two values will be the same, including all the number of decimal places. And as such, we need to move on to x3. And for us to get x3, then means that our n is equals to 2. So that our formula turns to be x3 is equals to x2 minus f at x2 over f prime at x2. So we're going to have our f at x2 is equals to f at 2.196, which will be equal to 2.196 cubic minus 3 times 2.196, then minus 4. And when you compute this, the value will be equal to 0.026. Then you also need to evaluate our derivative f prime at x2 to be equal to f prime at 2.196, which is equals to 3 times 2.196 squared minus 3. And this we shall get a value of, the value of this will be equal to 11.467. Therefore, we need now to substitute. We need now to substitute into a formula so that we can obtain our x3 is equals to 2.196 minus 0.002026 and all this over 11.467. So when you compute for x3, you'll get 2.196. And this is to 3 decimal places. So since now x3 and x2, they are the same, we say that hence the root of the function f of x is equal to 0 is approximately equal to 2. That is, it's approximately equal to 2. That is, x is approximately equal to 2.196. This is 2.196, like that. But also again, you can be given an equation, a question of the form. We can go to another question. We try. Check, you can have a question of the form. And have a question of the form. Let's just write this down. Introduce another lesson here. We check a question on the same. Let us have our blackboard back. Our blackboard, can get it by this. Can put our blackboard here, like that. Then you can now have a question of this form. Given, we are still on Newton. Newton-Raphson iterative method. We are continuing, so it can be given a question of the form. Example 2 can be given a question of the form. Given xn is an approximation, It's an approximation to the root of the equation the root of the equation 6x raised to power 4 minus 15 x squared minus 1 is equals to 0. Roman 1, show using Newton-Raphson method that a beta approximation is given by xn plus 1 is equals to 18 xn raised to power 4 minus 15 xn squared plus 1, all this over 24 xn cubic minus 30 xn. Now, this question, it wants us to use this function, which is of the form f of x is equals to 0, to show that the beta approximation will be obtained as xn plus 1 to be equal to 18 xn raised to power 4 minus 15 xn squared plus 1, and all this over 24 xn cubic minus 30 xn. Now, what we are required to do on the solution, we need first to state the Newton-Raphson method. What does it state? The Newton-Raphson method states what? It states that xn plus 1 is given by xn minus f at xn over f prime at xn. Now, what is our f at xn? Our f of x is given by 6x to the power 4, 6x to the power 4 minus 15x squared minus 1. And this now, if you evaluate at xn, we shall have f at xn is equals to 6xn raised to the power 4 minus 15 xn squared minus 1. And this implies that our f prime at xn will be equal to 24 xn cubic minus 30 xn. And when we differentiate, we see that d dx of a constant is always equal to 0. And also again, d dx of a x power n is equal to n a x power n minus 1. This is a reminder. That is a reminder. Now, we should substitute to our function. We have xn plus 1 is equals to xn minus, our f at xn is 6xn raised to power 4 minus 15 xn squared minus 1, and this over 24 xn cubic minus 30 xn. So what we are required to do in this, we should put our xn plus 1, all of it to be a single fraction that is under one denominator. We know that xn is over 1. So the LCM of 1 and 24 xn cubic minus 30 xn will be, we shall have xn plus 1 is equals to the LCM to be 24 xn cubic minus 30 xn. Now, if I take this LCM, I divide by 1, I will get 24 xn cubic minus 30 xn. So if I multiply by the xn, which is the numerator, we are going to have xn into 24 xn cubic minus 30 xn minus, if I take 24 xn cubic minus 30 xn, I divide by the denominator 24x cubic minus 30xn, I'll get 1. And so I'm going to remain with 6xn raised to power 4 minus 15 xn squared minus 1. So opening up the bracket and simplify, we shall get, we'll get our xn plus 1 is equals to 24 xn raised to power 4. When you multiply, when you open up the bracket xn and the xn, we say that in indices, if you have a raised to power b times a raised to power c is equals to a raised to power b plus c. So this is the concept that we are using when you multiply numbers or maybe variables that have the same base. And in this case, we have the xn multiplying by xn raised to power 3. So we shall have xn raised to power 4. And the next one could be minus 30 xn squared. Then you open up the bracket minus 6 xn plus it would be plus 15 plus 15 xn squared, then plus 1. And all this should be over 24 xn cubic minus 30 xn, like that. So putting the rectangles together and simplifying, shall get. So you can see we have negative 30 xn squared and also 15. So we are going to have our xn plus 1 is equals to 24. This one should be x cubic. It is x for let's power 4, it is all right. So we're going to have 24 xn raised to power 4 minus 30 minus 30. So this 6n, it says power what? 6n is power 4. It is also raised power 4. We have it raised power 4 like that. So that you're going to have, so we erase the 24. So you're going to have the 24x power 4 and also the 6x power 4. So when you get the two of them together, 24 minus 6, you're going to have 18. Xn is power 4. Then you have negative 30 plus 15, you shall get negative 15 xn squared, then with this plus 1 all over 24 xn cubic minus 30 xn. This is the required proof, but also again, we have the extension of Roman 2. It is clear that we have, if you can check here, we're going to have, you have the Roman 2 here. If you can check very well, this is Roman 1. Show that using Newton-Raphson method, that a better approximation is given by that. So let us look at Roman 2 of the same question. The Roman 2 of the same question says that it asks, the question is, hence find, so let us write the Roman 2. So Roman 2, hence find the root, hence find the root of the equation, hence find the root of the equation, taking the first approximation x naught is equals to 1.6. So give the answer correct in 5 decimal places. Correct 5 decimal places. Now, in this question, we are not going to start from the Newton-Raphson method. We will start from what you have already proved. We will start from what we have already proved. We have been told that, let us have the solution here. Solution. Solution. Already we have proved that xn plus 1 is equals to 18 xn is power 4 minus 15 xn squared, then plus 1, all this over 24 xn cubic minus 30 xn minus 30 xn. So we already have our x naught being equal to 1.6. So this implies that when n is equals to 0, we have x1 is equals to 18 x naught, this power 4, minus 15 x naught squared plus 1 over 24 x naught cubic minus 30 x naught. So we are going to substitute the value of this value of x naught to the equation where we have the x naught for x1. So we're going to have our x1 is equals to 18 multiplied by 1.6, this power 4, minus 15, 1.6, this power 2, then plus 1, all this over 24 multiplied by 1.6 minus 30 times 1.6. So you're going to have our x1 being equal to, we compute 18 times 1.6 raised to the power 4 minus 15 times 1.6 squared plus 1. Then put this over 24 times 1.6 cubic minus 30 times 1.6. So we get x1 is equals to 1.6015. So we want it to 5 decimal place, so it will be, the next value here to be 6. Then now we go to our x2. Remember, we cannot conclude at x1 because the x1 is the first approximation that you have obtained from the x0. So we need to check the x2. So for x2, it means that we're going to have our n being equal to 1, so that our x2 will be equal to, using the same formula, it will be equal to 18 x1 raised to the power 4 minus 15 x1 squared plus 1, all this over 24 x1 cubic minus 30 x1. So here you're going to have our x2 being equal to 18 into 1.60156 raised to the power 4 minus 15 into 1.60156 squared plus 1, and all this will be over 24 into 1.60156 cubic minus 30 into 1.60156. And this will be equal to, x2 will be equal to, substitute here, 1.6. We're going to have 1.60156, 1.60156, and have 1.60156, 1.60156. So we get our x2 is equals to 1.60155. So we proceed again to x3, and the x3 will be given by, so we shall have our x3 given by, when n is equals to 2, you're going to have our x3 is equals to 18 x2 is power 4 minus 15 x2 squared plus 1, and this is over 24 x1 x2 cubic minus 30 x1 x2, that is. So we have x3 will be equal to 18 multiplied by 1.60155 raised power 4 minus 15 multiplied by 1.60155 squared, then plus 1, and all this over 24, 1.60155 cubic minus 30 multiplied by 1.60155, like that. So we shall get our x3 being equal to, we compute using our calculators. Put the value, then you see what we're going to get. We shall get 1.60155. So clearly you can see that our x2 and x3, they have the same value, and so you can conclude here and say, hence x is approximately equal to 1.60155, and this is to 5 decimal places. So thank you so much for watching Mathematics Solution, which is the mathematics haven. The next we shall be meeting for probability 2. Thank you.